gauge setup. It's pretty flexible, it's pretty simple. You can slide these along, and this finger here can go out, and you can advance this bar, and that finger can slide in over the lower die, so you can bend half-inch bends or slightly less. I think probably around 3/8 of an inch would be the smallest bend that you could make with this setup. But then you can go and turn this around, and you can get close to the back of the dies, bring this out, and this gives you a little bit more area to catch the work on. You can also take these flat pieces, put them on the bottom, and let them extend underneath so that they can support if you're going to bring that gauge back, and the metal that you're bending is a little floppy, so it doesn't fall off the bottom of the back gauge and then you miss the bend. So that's pretty much how this is set up. And then I've got some nuts on the bottom. You just tighten this up, and that's kind of how this works. Here's the DRO setup. It uses two brackets. Here's the bracket on the end of the horizontal back gauge guide, and that just holds the end of the scale. And then you can see the reader, which is right here, and that mounts with a second bracket, which is on the back gauge vertical guide. It's a pretty simple setup. And then the end of the scale is up here near the anvil, and that just floats. So this has been set so it's parallel to the horizontal guide, and it's also parallel to the side of the press brake. So that's how the DRO was installed, and the instructions and details on all these parts are in the text in the thread post. Here's the OEM back gauge dial. This increases the bend distance. This decreases the bend distance. And the problem with this is there's about 30 thousandths of free play in it, and it makes it difficult to adjust. And truth be known, you're not really exactly sure where the back gauge is with respect to the dial that reads in the back here. Here's the DRO. Works pretty nicely. I'm cranking the dial here. The scale's reading the position of the back gauge, so you can see how this works out. Controls on this are pretty simple. The interesting thing is we can turn it off, and I can go ahead and move the back gauge, turn it back on, and it will read the new position. So it remembers 0 through on-off cycles. Inch and millimeter settings is nice. The OEM dial only registers in inches, so you can use this in millimeters. 0 is pretty self-explanatory. When you get to a point of registration and you want to zero the DRO out, you just press 0. There's also a feature, ABS, which is the default mode, but you can go to incremental, and you can do some incremental distances off wherever you press that button, and that will not affect the absolute distances, so that's convenient. This set changes the resolution of the fractional display. You can see that right in here, and there are 3 settings for that in terms of resolution. So I don't use it, I just use the digits, the digital display. It works out well. So that's kind of how the DRO functions. It's very convenient. Let's go ahead and do a 1/2 inch bend setup. I'm going to use the fingers, so you want to crank up your horizontal reference here so that these fingers can touch the back of the die. So I'm going to go around front and move these fingers in so we can get a 0 off the back of the die. So we'll crank this in just so these touch. There's a little bit of adjustment in here, so we'll push these fingers up, tighten this one down, and tighten this one down. So that sets the fingers against the back of the die. So the next thing we've got to do is zero out the DRO. Okay, so we're here at the DRO, and what we're going to do is just zero this out right here. So now we've got a zero registration on the back of the die. And the important thing is to know the distance between your bend center and the back of that die. So that has to be measured. In my die case, it's 0.562 inches, 0.562 inches. So you need to know that in order to do a setup. So we'll go ahead and we'll just crank this out a little bit so we can clear the dies. Then we'll bring the dies up and we will go ahead and crank them back in. So I'll power up the machine. We'll bring the dies up, and I'm going to reposition so you can see how this works. Okay, so we're looking through the space in the dies. I'm going to go around back and bring these fingers down so they just go ahead and sit on the bottom die. So I'm going to come in now 0.562, which will be negative on the DRO, so I'm looking at that right now. So we're dialing that in. Okay, I've got 0.562, so this edge now is right under the center of the bend. So I'm going to go ahead and zero the DRO out, and then I'm going to go back out to 1/2 inch. I'll over travel a little bit and then come back to 1/2 inch so that the free lash in the Acme screws doesn't misregister the back gauge. So I'm dialing it in now, and there's 1/2 inch on the DRO. So now I've got a 1/2 inch stop with respect to my bend center, so I can make a 1/2 inch bend. Okay, so we have our bend stop set at 1/2 inch. We'll power up. Got a scrap piece of 16th inch 5052 aluminum, so we'll go ahead and bend that. We can hit it one more time. Okay, so there's your 1/2 inch bend. Okay, here's our test piece of aluminum that we bent 1/2 inch. So I can use a precision parallel like this one here, which is a 1/2 inch. We can slide that right in there, and we can turn it this way. You can see it, it's pretty much dead nuts right on there. You also have to remember there's a radius in here, so these are perfectly square on the edge, so if you push that right up in there, it's going to ride up a little bit, so you want to back it off. But if you were real fussy about that, you can bring this back and take a second parallel like this, and go ahead and do this and check it. If makes an accurate bend, works out pretty well. So that's a 1/2 inch bend.